All right, so a quick proof trying to show something's a parallelogram. So for this one, you're given that AB, the big one is a parallelogram and that these are midpoints. You want to show that the smaller one's a parallelogram. So we got to think through all of the ways that we know how to prove something's a parallelogram. Because we know this is a parallelogram, that means that we know that we have opposite sides parallel. And so using the opposite sides being parallel is a good idea. And so the two theorems we have about that is if opposite sides are congruent and parallel, then it's a parallelogram would be one thing to do. Or we could go through and try to show that these two are parallel and use the definition. So either one of those would be a good way to do it. Thinking through what might be the easiest way to do it. It looks like there's no easy way to do it that doesn't use segment addition. So we are going to have to use segment addition. So we can start with saying that CN is parallel to AM. And that is just by definition of a parallelogram. I use the shorter lengths here, but it doesn't matter what you said because you could have said DC and AB, and that's fine because those are just part of those lengths are all going to be parallel because they're part of parallel sides because of the definition of a parallelogram. But what I don't have is anything about AM and NC except for the fact that we have these midpoints. And so that tells us that DN, and I'm going to use segment addition, so I'm going to set these as equal. By definition of midpoint, we know this is true, that those lengths are the same. This is equal to this, and this is equal to this. And so that is by definition of midpoint. And now we have to go through and make our segment addition argument. So we say the measure of, we know that CD equals DN plus NC, and AB equals AM plus MB. And that's just by segment addition. I also know what I haven't put on here that I should have is that CD is congruent to AB because opposite sides of a parallelogram are congruent. And so that means that CD equals AB. So now the ordering substitution doesn't matter too much. That's just definition of congruent segments. And so we can say that these two are equal to each other because these two are equal to each other, right? So I can say that DN plus NC equals AM plus MB by substitution. I can do another substitution. I want CN equal to AM, so I'm going to plug in the CN. So I get NC plus NC equals AM plus AM. That gives me 2NC equals 2AM. By substitution. And then I can finish this out by showing that NC equals AM by division. And then that shows us that NC is congruent to AM by the definition of congruence. And so now, finally, I've shown that opposite sides are congruent and they're parallel. And so that's enough to show that AMCN is a parallelogram. And our reason for that is if opposite sides are congruent and parallel, then it's a parallelogram. So that one had a lot of steps because of that segment addition in there, but it was really just a matter of showing these are congruent, these are parallel, thus it's a parallelogram.